plus 4H plus NO3 minus yields NO plus 2H2O. So I have 3 negatives, 4 negatives, and 4 positives.
Wait, how's that 4 negatives?
Three negatives, 4 negatives total.
How is that 4 negatives though?
3 plus 1.
I feel. I thought that it was.
I know what you're saying. You thought I was saying that that is 4.
Yeah.
No, it's a total of 4. Total of 4. Okay. So now we have a case where there's 2 being lost here, but 3 being gained here. And that can't happen. Remember, if I lose a $20 bill, somebody finds a $20 bill. I don't lose a 20 and somebody finds a 50. Right? Whatever's lost is going to be gained. So what I'm going to do is multiply both of these equations. So this equation, what am I going to multiply by? 2 to make it 6. I heard somebody say 6, but yeah, we're multiplying it by 2. So I'm going to rewrite this as 6 electrons plus times 2, 8H plus 2 NO3 minus yields 2 NO plus 4H2O. So I multiplied that one times 2. What am I going to multiply this one by? 3 times, right? So I'm going to write all that down here. Because I'm going to recombine these. I like to line up my arrow so I don't get confused on what's a reactant and what's a product. And so I'm going to have 3 copper. And I'm going to have 3 copper plus 2. And 6 electrons. Now I'm ready to combine these 2 half reactions. So I separated them off, and this is more for Ian's benefit right now because you guys are just starting to film. Went through, we identified the oxidation states based on our rules. We figured out that this is being oxidized because it's going up in charge, or meaning it's lost some electrons. Oil, rig, lost, oxidation is lost. Reduction involves gain. This number went down from 5 to 2 because it gained some electrons with the oil rig. Then we go through, we split up our half reactions. So there's my oxidation one, my reduction one, I write them down. I balance other elements other than H and O, which there was nothing to do because they were already in balance. I balance oxygen first using water. So I did that here. 3 O's, there's 1 O. I added 2 more O's using that. Nothing to do here. I balance H's using H plus because again, this is an acidic solution. So there's water there, there's H plus there. So these 4 H's get balanced up with that 4H plus. Last thing I do is balance charge, and I'm going to add electrons to balance charge. I always add it to the more positive side, so this brings this side down to 0 to match that. That 3 negative plus that 1 negative makes 4 negatives, and there's 4 positive. That makes this side neutral. That side's neutral. We're good. Now we have an uneven electron exchange, 2 and 3. And so we're going to bring them both to 6. So we did that by multiplying this equation by 2 to get this equation by 3 to get this.
So, how do you figure out how many electrons are needed?
You got to make the electrons. You got to make each side equal. You got to balance it. So whatever
you
side.
just put however many electrons it is to take them to get balanced.
Yes,
So
exactly.
If that other one was, if it was like, oh no, never mind, that would make sense.
So it's not even like it's not. I guess the thing I would point out is you're not even necessarily making them neutral. This just happens to be a coincidence that that's neutral. This is plus 2, and I had to make it neutral. And it's just a coincidence that this side is neutral, and I had to make this side neutral. You could balance them both by being -6. Maybe both sides balance up at -6. I'm just balancing them to get it so they're equal. So like if I have one side of the equation, let's say, is plus 2, and one side's plus 4, I would add 2 electrons to this side to make it plus 2. I'm always just bringing the more positive side down to the less positive side.
And this is what you did yesterday, right?
Yep.
Okay.
Okay, now we're ready to combine. Cancel any species that are duplicates. So your electrons better always cancel. If your electrons don't cancel, you didn't do it right. That's the whole point of this, is to figure out how that works. And I look and there's nothing else to cancel. Sometimes there will be H pluses to cancel. Sometimes there will be water to cancel. And in fact, sometimes there might even be things to add. So let's say, for sake of argument, let's say I had 3 Cu here and a Cu up here. If they're on the same side, they add. If they're on opposite sides, they reduce. So that's just things that are going to be coming up in future problems. So 8H plus 2NO3 minus plus 3Cu yields 2NO plus 4H2O plus 3Cu plus 2. So does that make sense? 8 H's, there's my 8 H's, 2 nitrogen, there's my 2 nitrogen, 6 oxygen, there's 4 oxygen, but I got 2 more right here. There's 6, 3 copper, 3 copper. Charge over here is plus 8 minus 2 plus 6. This is plus 6. You guys ready to tackle one? We'll find out. Second. It's not as bad as it looks, it's just it's a process.
And this will be one of the 2 problems on the next test.
Yep. Yep. And again, there's some things that crop up that are additional, but we'll tackle them as they come. All right, we good?
You'll never have to go to a periodic table, right? Because you can just use those rules and then find it based on.
Yeah, pretty much. Yeah, you probably will not need a periodic table too much for this, but I'll still give it to you. But,
Okay.
so it just is a coincidence, again, that the first 2 problems that we've looked at, that we had one equation that we didn't have to do much. But just go through the rules, you'll see. So maybe in the next one, maybe that's what it comes up. I don't know. I don't remember. Okay, so let's do 74B. 4B, let's see. So CR2O7, this is dichromate. Dichromate reacting with chloride ion to form chromium 3 plus chlorine gas. Okay. So how about the first guy we call up, you do the oxidation states for the reactants. The second guy do the oxidation states for the products. Make sense? Okay. All right, so first guy is going to be, let's see, first guy is Race. So you're going to do oxidation states for the reactants, and Ronnie for the products. Does Rodney not go into his homework he did last night? Did you notice that? It wasn't yesterday, it was 2 days ago. It was Tuesday's notes. The 3rd.
Is it Thursday already?
Isn't that awesome? Nice. No, that one won't be zero. Plus 3, it's a monoatomic ion. Okay. All right. So just to make sure you can read this. All right. This one, he's right. I'm going to write it just so it's a little bigger. He wrote down -2. He circled it. And he said times 7, which I'm fine with. Okay. So Ray said each O is a -2. Since I got 7 of them, that comes out to -14, right? We good with that? It's got a total -2. So this thing has to total 12. And again, I'm just writing it to make it bolder. this is plus 6. So that's good. And you call this one -1, because that's a monoatomic ion, and it's got to be equal to charge. That is 0, because it's an element. This is +3, because it's a monoatomic ion. Right? So how about Carson, you come up and identify oxidation. Gary, come up and identify reduction. So we're just going to circle, connect the dots. Yep. Yep. Yes. Carson, you have oxidation. Gary has reduction. So think about oil rig. Oxidation involves loss. If you lose electrons, your charge will go up. That's reduction. That's okay. So you go ahead and do reduction like Gary do oxidation. So think about it like this. Oil rig, right? Oxidation involves loss. If you lose electrons, you become more positive.
Oxidation is gaining, right?
Oxidation is loss. Oil rig. Oxidation involves loss.
I'm doing oxidation.
I gave you, you're going to be oxidation down because Carson went the other way.
Okay.
I changed it up on you. I switched you up, man. Kind of like Digeer.
Loss of electrons.
Lots of electrons, yeah. That was so funny, man. That was almost as funny. Okay, I don't think you were on the team when Wagner was on the team, were you? I think you might have been. You might have been in middle school. But there was one kid, we were wrestling, I forget who we were wrestling, Connie or something like that. And he came down this last match, and he's not an experienced wrestler, right? And right at the end, they're in like a 19-17 match. One of those kind of like just rolling around and stuff. And we're finally just stay away from him. Just circle, right? We're saying circle. So when he started, you guys don't know, circle means don't back up because that's called stalling. Right? So circle just means move your side and just keep in the center of the mat so they can't get you, right? He starts literally running in a circle around the mat. We're all like dying. Okay. All right, so let's see. Again, oil rig. Oxidation involves loss. If you lose negatives, you become more positive. So oxidation, this is going from a negative to a more positive number. That's your oxidation. Reduction is just like it sounds. The number goes down because you've gained. Reduction involves gain, right? If you gain negatives, you become more negative. So here's a +6. There's a +3. +3 is more negative than +6. Okay? All right, so now, how about Trent? Over here, and again, we got to be concerned about space because you guys see how much space it went down before. So Trent, how about you write your oxidation half reaction, and Matt Berry, you write your reduction half reaction. No, all you got to do is just write it, and we'll have people come up and do step by step. Is that dead?
Yeah.
Bad. Now, Trent, I want you to double check. You're supposed to be doing oxidation, right?
Oh.
And even if, let's stop. Even if you were doing reduction, do you see what problem you have?
Yeah, I didn't add the CL. So the CL.
You wrote, yeah, you got to write the entire thing, but you're not doing that one, so let's go back. So. And that's all you have to do, Matt. You've got yours done, right? Because you connected the two things together. No, I'm going to have everybody go step by step. Okay, so John Lupo and Nick Nicolo. All right, what's the first thing you got to do for each of these things? Balance. Nope. Order matters. This first step, balance everything.